mathematics is really very precise. And sometimes you can gloss over precision, and sometimes you have to deal with it. And so, take a look at this. Everybody who has an exclamation point did really everything I would have expected of them. But in a technical sense, nobody got it right. This one. Do you have a paper up here? So what most people did properly is they said, well, the cotangent, that's the cosine of the sine, right? And the cosecant, that's 1 over the sine. And so we just kind of cross this off and cosine, right? And that's really all I expect from anyone. But I digress for a second. We've been talking a little bit about functions and their domains and ranges. And we kind of treat it as like an appendage, you know? It's like you've got a function, but it also has a domain. But it's not really that way. It's the domain is not this thing that the function owns. It's part of the function. So I said f of x is equal to 5, x between 1 and 0. I said f of x equals 5 between x is between 1 and 0 and 2. These are not the same function. It's the same rule, right? It's 5. It's not the same function. And this is not the same function as this. It's almost, but it's not. Does anybody see why it's not the same function?
What is not the same function as what?
Saying cotangent of theta over cosecant of theta. Well, that's cosine over sine over 1 over sine. So we can kind of cross off the sine. And so it's cosine.
Oh, because you have to avoid dividing by 0?
You have to avoid dividing by 0. How do you avoid that? Well, this has a different domain than this. Now we can fix that really easily. We can say cosine of theta where sine of theta is not 0. That's the right answer. Right? A little nit. Not so important today, but you know, I can say mathematics is precise. Let me start by asking a question. Who here has taken geometry within the last 2 years? 3 years? 3 years, okay. 4 years? Oh man, that's a long time ago, isn't it?
It's like this. 6 years.
Yeah. Back in the dark ages. I really hate.
Yeah, I like your hair coming. I never remember.
I hate
Fucking bullet, right?
I'll bet you're not the only one either. Okay, so
Business in front, party in back.
we're going to do, because it kind of just suddenly shows up here in the middle of the trigonometry, we're going to do just a little review. I talked about some of this before, but I want to talk about triangle congruences. And there are a few of them. Congruence, let's say theorems. You'll see why I want to go over these in a minute, but does anyone remember any of them? They all have letters for names. Some of them have 3 letters, some of them have 2 letters. Sean? Oh, they're over there. Oh. Okay, now you have to
Side, 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 angle, side.
well, you know what the S is mean, right? Okay, so side, side, side. Side, angle, side.
Never angle.
It's a Zelda reference.
Side, side.
Yes.
But it's am I supposed to just fold those right now?
I'm going to put in parentheses angle side.
You're gonna have to explain this to me.
Because you
How do you
have 2 angles, you have a 3rd angle. And then there's one more.
you can plug it in?
Angle, side, side. Don't remember, that would have been a real good joke in class, wouldn't it?
Yeah, they also
Make it
use
pass,
same
that's
thing.
It's still no good. That's not a triangle congruence theorem. We're going to get to why that is. That's actually really important. It's called HL, which is kind of, you know, angle side side. There's an angle, and a hypotenuse, and a leg. So it's kind of angle side side. It works because the angle's a right angle, but it doesn't work otherwise. Okay, so what do these theorems tell you? They tell you have 2 triangles, and you're trying to figure out, are they the same triangle? Right? Same sides, lengths of sides, same angles. But they should tell you something else. What they should tell you is, let's take the first one, side, side, side. If you know the 3 lengths, you know the lengths of the sides of a triangle, all 3 of them, that triangle is determined. It is what it is, it can't be something else. There's no flexibility. Likewise, side angle side, you know, you set 2 sides to some value and the angle between them. That's it. That triangle is done. It can't be anything else. Now, that's true for these 4. And what's different about this one is that if you have 2 sides and then another angle that's not between them, and it's not a right triangle, then you haven't completely determined it, the triangle. There's actually 2 possibilities, or none. So here's kind of the way that works. You have some unknown side here. You have an angle. You have a side. And then you have one more side. So let's say, there's a ruler here. Let's say that side is a nice number 11. So whatever this is, we know what it is. We know what the angle is. This side is 11. Well, if this side is 11, we have another possible triangle here that also has a side 11. You've got an isosceles, you've got a acute triangle here on the outside, and on the inside here you've got an obtuse triangle. So SSA only determines you down to 2 possible triangles, which is pretty good, you know, an infinite number. But there's a catch too here. What if you know this angle, and you know this side here, but this side is only 5. What do you have then? You don't have a triangle. Yeah. So that doesn't really determine a triangle. Kind of determines nothing. Okay, so why am I all jazzed up about these? Well, what we're going to do today, oh, now I can turn it over. We're going to talk about solving triangles. And what we mean by that is, given information, minimum information about a triangle that is determined, we want to know everything else about it. And we're finally at that stage where we can do that. Well, we're almost at that stage. We need a couple tools we're going to develop today, but we're pretty close. Okay, so let's start off with something easy. Here we have a right triangle, and we know by hypotenuse leg that this is determined. So, but we've got some missing parts here. We don't know what this leg is. We don't know what these angles are. So how are we going to find those out? This is easy. Everybody here already knows how to do this. Take a look and think it through. How do we find that? How do we find some information about this? Good. Okay. Everyone hear that? So 5 squared plus 4 squared equals, oh no, I didn't do that right.
You need to zoom out or speak better.
4 squared plus question mark squared equals 5 squared.
Zoom out or speak the paper.
So 16 plus something squared equals 25. So that something squared becomes 9. Oh, it's that really nice 3, 4, 5 right triangle. Okay, that's good. Good start. We still have 2 angles to figure out. How can we figure out one of those angles? A trig function, but more specifically, but an inverse trig function. Well, you'll see. What does trigonometry tell me about this triangle, about this angle here? Right? Call that x. We know that, for example, the sine of x is equal to what? 4 over 5. So to find the angle, I guess I should use this machine. It's supposed to have a preview screen here. Okay. So inverse sine of, I want to check my mode first. Yeah, I need to previously, okay. 4 divided by 5. Okay, so I get this uncomfortable number. Okay, good. We found one angle. What about the next angle? We'll find that.
Add the 2 angles and subtract it from one.
That's the cheap way to do it. I mean, cheap equals good, right? Elegant, right? You can just, you know that these 2 angles are complements, so you subtract this from 90. You have to.
You could also use a trig function or something like that.
Absolutely, you could use the trig functions the way we just did. Notice that in this triangle, it's got everything going for it. We could find the tangent, the inverse tangent of that angle x. That's just sine over cosine. 4 over 3, inverse cosine, anything you want, you can do it. Okay, so those are easy. All right. Oh, here we go. I used the cosine. Oh, I'm finding the other angle. Okay. All right, let's look at a somewhat more general triangle here. This is side angle side. We want to be able to figure this one out. It has a nice angle, which it doesn't have to. I just did that to make it easy. But it's the same process of whether it's a nice 30 degree, 60, 45 degree angle. All right, what do we do here? Well, I've written in too much here, but I'm going to drop an altitude, and as soon as I drop that altitude, I know that this distance here is 4, right? I know that because my right angle is a what? It's a 30, 60. Oh, wait a minute. This is terrible. That doesn't look right. That's not a 30 degree angle. It's a 60 degree angle. That's a 30 degree angle. Okay. Let's start over here. 60 degree angle. So this side is 4 because it's a 30, 60, 90 triangle. The hypotenuse, the altitude, leg, is 4 square root of 3. And I know that this side is 6 because 10 minus 4 is 6. And finally, I can use the Pythagorean theorem again, using this side, the altitude, and this to find this side. Okay. Oh, wait a minute now. That's good. It's just like I wrote here, except I erased it. Square root of 4 squared, 3 squared, plus 6 squared. That's what this hypotenuse of this right triangle is. But I still don't know these angles, do I? Am I going to find those? All right, so that's a question. We don't know how to do that quite yet. All right. What about this guy here? This one's even worse. We drop an altitude, but that doesn't do us any good because we don't know which of these is 10. I mean, you know, what part of 10 each of these is. So, but we know these things are determined, right? So we ought to be able to figure them out somehow. Okay, so we need a couple more tools. Oh, and one more here. And I think we just ran into the side, side, side. How do I find the angles? It's not a right triangle. I don't really know. So what we're going to do today, mostly, is we're going to develop two new, we'll call them theorems. The difference between a theorem and a law. We're going to develop what's known as the law of sines and the law of cosines. And these are going to be our tools that are going to enable us to solve all these weird triangles. Be able to figure everything out. Okay, has anyone run into these before? Okay, so some of you have taken trig before, so you know about this. All right, let's start with the law of sines. We're going to start with a triangle here. We're going to label its points with capital A, B, and C, and its adjacent sides with small a, B, and C. Small a, B, and C are lengths, and capital A, B, and C are going to be angles. Okay, so as in that example, we're going to drop an altitude, and we're going to give it a name. We're going to call it H. H as in height. And we're going to make two observations about that height. Right? We can see right away that if we look at angle A, h over b is now the sine of A. And likewise, h over A is the sine of angle B.
I think you need to move the page up.
Yeah, we don't.
Let's see where you're writing.
Ah,
There we go.
If you zoom out, that'd be easier.
it would be easier if this, we try one more time. It would be easier if this preview screen. Sorry. All right, just yell at me if something doesn't look right. Okay, let me try that again. H over B, sine of A. H over A, sine of B. So we're going to take those two equations and we're going to solve them both for H. All right, we multiply this one through by B, and we get H equals B sine of A. And this one we multiply through by little a, and we get H equals little a sine of B. Well, now we have two things equal to H, so we can equate them, right? It's called transitivity. And now what we're going to do to both sides of this is divide by little a, little b. What we get here is, okay, we'll zoom in on this. It's not big enough. We do get that the sine of angle A over the length of side A is equal to the sine of B, angle B over length B. Well, that's really handy, but we're not quite done. Just in your mind, go back to that diagram, draw the other two altitudes if you wish, do the whole thing over, and we'll get that all three of these ratios are the same. Sine C is also over side C is equal. Right? This is the law of sines. Well, you can bring it in on a card for a quiz. You really want to know this. It's really going to come in handy for what we're going to be doing. Okay. So, given any two angles, and a corresponding side, any two sides in a corresponding angle, you can calculate the missing side or angle. That's the law of sines. Okay. I want to do things out of order here. Back to the law of cosines. Okay. Let's go back to this problem here. That's not the right one. Yes, it is. Okay. So we were asking earlier, how do we find the missing parts for this guy? Wait a minute. Oh, well, there's one missing part that's pretty easy to find. Anyone tell me what that is? Third angle, right? Third angle has to be 180 minus 48 plus 57. There's a minus sign. So what is that? 90, 105. 180 minus 105 is 75 degrees. Okay, now we can use the law of sines here. Right? We have sine of, doesn't want to focus, sine of 75 degrees over 10 is equal to sine of 57 degrees over b, which is equal to the sine of 48 degrees over a. So we solve by cross multiplying, right? And solving for a and b. we get two values. Let me see how I did that. It's not too harsh. Okay, so that's how we use the law of sines. All right, let's back up a little. Now we're going to do something a little harder. We're going to look at the law of cosines here. I have a question. What I just did with the law of sines, we call that like a derivation or a proof. I'm wondering if anybody noticed what's incomplete about it. It's not really a complete derivation. I'm not going to do the whole derivation. Gave you a triangle, right? Said drop an altitude. And I started doing stuff. And let's see why that isn't always going to work. Okay, well, I'll get you guys thinking this way.
Angles to make it work.
Hmm?
At least 2 angles to make it work.
No. It's not. That's not the problem. I mean, you know, I have 2 angles, right? Well, okay. I mean, I have 3 angles, really. The problem with it is that not all triangles look like this. Some of them look like this. So if I drop an altitude here, so here I just said, well, this is H and this is, I forget A, E, and C. And what happens if H is over here? Well, you kind of do the derivation in the same way to get the same result, but you need to do that. I mean, it could have turned out different, right? It just doesn't. Okay. Law of cosines. Again, we're going to start with a general triangle. And again, we're going to drop an altitude, H. Only this time, I'm going to give this section here, I drop the altitude to point D. I'm going to call AB X. And since AB is C, I'm going to call DB little c minus X. So I'm just giving some names to the parts of this. And I note that the cosine of A, it's this angle here, is what? It's X over, I don't want to have a big lead here. I want a little lead. All right, we're going to use this at some point. That little b, we're going to get, wait a minute. I think I did this all backwards. That's terrible. All right, write that again here. It will be cosine of angle A equals X. All right, now I want to use the Pythagorean theorem. On both of the 2 right triangles. Right? Everybody see the 2 right triangles here? All right, so, yeah, I guess I did this all wrong. On the left, I have b squared plus b squared equals h squared plus x squared. Right? Pythagorean theorem. On the right, let's see, I have a squared is equal to h squared plus c minus x squared. And I'm going to do something similar to what I did with the law of sines. I'm going to solve for not h, but h squared. And so I get these 2 equations. The one on the left is h squared is
squared minus x squared, and h squared equals a squared minus c minus x squared. All right, so h squared is equal to h squared. Oh. And now I'm going to equate those two. Just going to leave these letters here for the time being. All right, I want to multiply this out. I hope you'll remember how to do that. FOIL, everybody know FOIL? So I end up on the left, b squared minus x squared. On the right, a squared minus c squared minus 2cx plus x squared. Oh, I run that minus sign through, right? This is great. Something drops out here. I've got x squared minus x squared minus x squared. I'm left with, and now these are the sides of the triangle. B squared equals a squared minus c squared plus 2cx. Oh, but wait. Remember early on, I figured out what x was equal to? Remember what x was equal to? X was equal to b cosine a. All right. Yeah. So let's plug that in here. All right. That didn't work. No, it didn't work. So what do we have? We have a squared equals b squared plus c squared. What does that look like? Looks like the Pythagorean theorem minus 2bc cosine of angle A. This is called the law of cosines. The sides that we pick for A, B, and C are arbitrary. So you can rearrange it. Let's just put it on the board. All three ways. You can have a squared equals b squared plus c squared minus 2bc cosine of angle A. Or you could have b squared equals b squared plus c squared minus 2ac cosine of b. Or c squared equals a squared plus b squared minus 2ab cosine of c. So what does this relationship do? It gives us some way to look at three sides and an angle. So if we know two sides and an angle, we can find the third side. Or if we just know three sides, we can find an angle. Do you know how the temperature is controlled in this room? We have no control over it, do we?
As long as the thermostat, I'm not even just
I'm in a t-shirt and I'm sweating here. I don't think we can do Call the fire department. Okay, any questions so far on this? All right, we have these. We have the law of cosines, I guess. Draw the law of sines up here. So Okay. All right, let's just take a look at a problem where the law of cosines is going to help us out here. So here we have a triangle, we have three sides, and we don't know anything about the angles. Right? But we can apply the law of cosine. Well, this angle x up here. And we have 7 squared equals 5 squared plus 6 squared minus 2 times 5 plus 6 cosine of x. Well, we solve for cosine of x. We get this ugly expression here. And then we find the inverse cosine. And we come up with 78.46. It's pretty straightforward algebra.
That's our only example. Or do you want us to prove it and we just did, or you want us just to know how to apply it to this triangle?
No, not expect you to derive it. You need to know it, and you need to know how to use it. It's there to show you that it didn't pull it out of my Okay. Okay. We can find the other two angles the same way, using the law of cosines. And we can always find the third angle by using the fact the sum is 180. Okay, that's almost everything. There are some surprises. Let's try some problems.
There's no more?
Yes, you didn't get one?
Isn't like
They don't like it, I guess. Oh, you didn't get one either?
You gave me one.
Oh. See what you get for being nice?
what?
Yeah. And the A, B, and no, that's, yeah. Those are consonants. Huh? A, B, I don't know. You'll notice in these problems I don't give you a diagram, so you're free to use any legitimate diagram you wish.
Was it trying over length or was it length over time? Over time.
Now, Lillian, if this is the case, what would I have to do to show their reciprocals?
You would have to know at least 3 of the 4, and then you can divide or multiply both sides by for your second one, which was created by the following right.
I think so. Look at that. You could just kind of say if something's equal, its reciprocal has to be equal, right? That almost always works, doesn't it? Where doesn't it work? Say the sine of pi. You can't really have an angle of pi, can you, in a triangle? You have the sine of 0, that's not a triangle.
Just remember these things.
I'm not very much. I just want to recover. I'm in two.
Why didn't everybody try and get to the first four? They're the right triangles, and when you're done with those, let's stop for a minute.
For you, it doesn't matter for. It's not the one wrong.
Yeah, so you remember. It's a right triangle. It says at the top. Yeah, it makes it easy.
I'm talking about say that. I'm talking about it was.
It really doesn't matter who they get, as long as realize cross capital. That's all. It's important sense. Yeah, capital, lowercase. Yeah. Capital triangles. Use of A's and A's. B's. I know that. So then we just do that. So
Actually, it might come out C.
are we help us?
Right?
That's not done. And found the second. Something 77 times 7.3.
See the angle, big letters of the angles.
That's the other side.
So, H over B, height of the length of the altitude, is sine C. Opposite over that C. Similarly, H over C is equal to sine of. So I multiply this through by little b. And I multiply this through by little c.
But how would you know what you want?
When you can't do all signs,
Now I equate these two. Substitute.
usually if you're given
Z equals cosines.
So how would you find?
Now I divide by EC.
You look at angle,
Little b, little c. I divide both sides by little b, little c. May not skip that step.
That's a step where you're okay.
EC.
So then you get it up.
Sine C. And if you change the letters around. It's not that hard. Just,
first you take, you find your attention. What I do, I always this is going to be your primary defined, which is going to be some wall signs. All you do, if you need help, so we are okay to break down the equation, basically.
Is anybody not finished with through 4? Anybody still working on 1 through 4? Okay.
Yeah. Isn't that your room?
Yeah. We have basically signs, this is C, right?
So basically, I'm trying to.
And you take it. It's not.
It's interesting. I can see it's very good.
Yeah, they're interchangeable. It's just the opposite. This is what it is. And then this up here, so it's going to be C to the length C times your angle B over angle C.
It's because C is already given, right? So then
B is
C is given. So you just cross it.
this.
So then it would be C, so then you transfer 27 sine of E, which is 67. Yeah, 67 degrees. Because the triangle is 180. So I did 180 minus 23 plus 9.
Okay. Or B.
I use C, C again. Yeah.
And C is not
It's fine.
C, B, E, A. We use this angle, this angle. We use
This angle. So then we do just sine.
your answer's right.
Yeah, that's fine.
The sine of x is but that means you have to use the right hand. Okay, so then what you did is you added a little bit of C, a little bit of B, and a little bit of A.
Because I was following you. That's what's for the sine of C. This is a good thing.
Yeah, sine of C. Sine of C is not 27. It's divided by.
So it's supposed to be the opposite over, right? Like the right from C.
It's not, you don't think about it. It's in you need to think in angles and sides. That's it. You're not thinking this being this.
Of course.
That's all. You have given signs and you have given angles. You use those.
There's a right triangle, right?
You don't worry about what the sides of the into that. That's what one. It's going to be fun. It's 24. Yeah, it's still good.
So
This would be this would be for A, right?
No, that would be great.
That's what most people
you can't do that without
Let's get 5 and go to 6.
Okay, so then 6 and 8 are I'll read those all over again.
That's a lot harder.
Which is why I think we do this. So then,
That's why we do practice. We're not using the
yes, I first I want to know and then I need some D.
And then final score.
So let's start with my A, right?
You're not doing that.
It's just for mine.
Well, I mean, I know.
Did you write it? Write down.
Okay, so all over.
You get the
I
answer.
want to get the let's say I'm going to right?
You have one angle on one side. You have an angle that also has a side.
Now,
This is how you know that. You have an angle on all the side. That's not a question. I asked if you had an angle against the side.
inverse sine.
You gotta do that.
23 and
Well, so you're saying like, take the C
So
value.
when I'm asking whether you can.
No, it's not going to be over. If you do that, we're going to tell you, you can do 45.
Oh, so yeah, C.
You have one. Then you can use that's how you. You have both.
So the inverse sine is this.
As long as you have another one, or side, you can divide.
You always
You have
This is really dark.
So then,
But yeah, this can also be C over sine C. Like the reciprocal of the
90
same.
degrees over 27.
This one's pretty
So
easy.
you can go side.
Yeah, I know.
What is the side on top?
I'm not sure, I think you said it's about
Okay.
2 or 3 weeks.
Okay.
About 2 weeks, something like that.
So then we do what?
You're looking for a sign, the side has to be.
So we do 27 over sine of 90.
Yeah.
I'm retrieving hard.
Equal to the side of the side of the pencil.
Yes, the side.
No, I didn't say side,
I
I
don't know.
said side.
Yes, I.
It's
Sorry.
cover
Yeah,
everything.
that's
So
left.
for
We should be putting it left.
Oh, side of looking for, okay, sorry. That is
Everything else
A.
to cover. So it's gonna go.
So,
What's
I just,
Yeah, there's something missing from that. What you got, you told me the question, find the pieces and no, don't look at your, I said look at the equation.
oh, sorry, so A.
Yeah. Yeah, unless I ask for, like, say, round to 2 digits, whatever.
That guy's digital.
Yeah, so I'm trying to find for.
Unless I ask for an exact answer.
Something else more fun.
I ask for an exact answer.
Yeah, but where's it go? In your equation, where's it
Yeah.
go? Sign. And you don't have to figure out. Line itself.
Is everybody done with 1 through 4?
No.
No. Is everyone done with 1 through 3? All right, why don't we take, those of you who are all done, why don't you take a break for 10 minutes? And those who aren't done, work.
Wait, crap.
I'm going to go over there and see what's going on.
Should we maybe cross multiply?
You can't cross multiply because you need to find that. But what you do is you take the denominator away. What you have to do is
At times.
yeah, multiply each side.
Sorry, from there we can figure out, right?
You already have to.
No, I-
You have to.
Yeah. And I just want to understand, that's the thing.
And if you ever get signed, you get signed zero, signed by
So then small a,
Right, let's move on.
well, I still haven't done that. That's the last one.
You got that. Let's just move on. It's there.
Isn't it?
Good question.
8, 9?
For a right angle triangle, are you allowed to use these signs?
Yes. Okay.
Really?
Well, that's because most of
You don't need to,
It's great.
but you may.
Really?
This is true for all. In fact, if you have a right triangle,
Alright, now you're gonna take a
and you look at the law of cosines for a second. So let's say, let's take the first one. Let's say our right angle is A. Right? So that tells you A squared equals B squared plus C squared minus 2AC times the cosine of 90 degrees. What do you cosine 90 degrees?
For any of them, right?
Because
Zero.
you're assuming the hypotenuse is C, so the angle C has to be.
And what do you get?
So this the hypotenuse is C.
Now, if you use the law of sines, that might be a little more helpful. But
Your hypotenuse is C.
wait a minute, hold on. So let's see.
Yes.
This is angle,
Yes.
I'll call this angle A and B and C. And this will be little c, little a, and little b.
This
is a right angle.
You can make a small diagram.
So let's look at the sine.
That's what the point is.
The law of sines would tell us.
This, right?
Says the sine
What do we want to find first?
E over
Or we can find
equals sine of A over big A equals, I'm just going to write H.
Now,
Hypotenuse over H. What's the sine? What's the sine of C? It's the sine of 90 degrees.
What's the answer?
Sine of C, 90 degrees. What's the sine of C?
No.
Sine of 90 degrees is
So, like,
One.
start by writing the right.
right? So
Secret, start with writing what you're
So let's look at each of these separately. Sine of A over A equals 1 over H.
Starting to get that.
So let's cross multiply.
All your information that you have.
Or actually, let's just move the A over here, right? Sine of A equals A over H. Oh, well, that's just opposite over the hypotenuse, right? Same thing with B. So there's not really, when you use it on a right triangle, neither of these is telling you something you didn't know already. But yes, you can use them.
For these right triangles, you would work.
My teacher always told us you never use one.
You should never use them?
Yeah.
Well, what I'm saying is, you don't have a reason to. That's not the same as you should never use them, but these laws are true for any triangle. No matter how you label it either. You know? In other words, if you have an obtuse triangle, you label the obtuse angle A, B, or C, and these all have to work.
You take the sine and cosine on a non-right angle.
Sine of, you said sine of 90 is 1, right?
See, you made a mistake again. I'm gonna let you figure it out.
Because I did.
I'm gonna let you
Oh!
figure it out.
No.
Now read it again. Read it very carefully. Compare your list. There's something very, very wrong there.
Okay, that makes sense.
Although you're right in a different sense. I'll say it is in a second.
Every angle always has.
Okay, so then, because I was trying to separate A by itself.
Yeah,
So
now
then-
look at that.
That needs to be sine 90
I don't understand what you're saying. You can,
A is 90 degrees.
Yeah. But what
you can come around and draw the picture. And I don't have to turn my head.
And figured it out yet. You found it. Anyway, it's not the one you're looking at. You found something.
Oh, you don't need to use you just use the law of sine, right? So the sine of this, this.
Yeah,
It's
Sine of this.
A's a number.
This is how you do it.
Sine of
Oh, it's going through.
Well, no, because you need the regular trigonometry to be used. I mean, these are right triangles. You need a right angle. Now, you know, create a right angle by doing that. That's the trick we did. Right, because otherwise there's no opposite.
The long right?
Yeah, so solve for this one.
Yes.
We got all these.
It's kind of neat party parade.
Yeah.
There you go.
Unless it's say 30, 60, or it's going to be ugly. There's a reason they call them transcendental functions. It's like irrationality. It's not, it's less fun.
This is where it gets
More fun.
Okay.
Did you get to me one more time?
This is where it gets
So let me have two sides.
Yeah, you see, you only just get a tiny stretch the whole time, so it gets the next one. It changes.
You have to like.
Yeah, to which then you this side.
No, you can. Yeah, you can. This is just, I keep forgetting how to use it.
Oh,
Yeah, you can use it. So,
This is not
C
easy.
is equal to 90, I totally forgot that was there, sorry. So, yeah, you can use it.
So, tangent is,
cool. I sure changed.
Oh, no. That was wrong. Yeah, you have to use the law.
This one?
From the left.
So, yeah,
You don't have to do same size as man.
You see the moon?
Alright, so now we're gonna look at this. This is where it gets fun. Which is what we're doing. We're gonna be looking for the side of the element. And so we're gonna be looking for, so use this word. This is it, there's gonna be, I have all six written out, it should not be hard.
Yeah.
So basically, what we're doing, you're given A, you're given B, and you're given cosine of use this. So this is where we start doing.
Oh, for the
I can't even get near some of these.
You can use
It's
long
essentially
signs to solve.
going to be, you're gonna use a lot of cosines first, and then you're gonna use
For
the
these
long
ones,
sines to find
one last block.
Yeah.
Alright.
For the first two, you probably use long signs. Or
Oh, no,
Easy.
yeah.
for the 3 and 4, you use long
So it's going to be
for the English.
yes, no, trying to find the side. So it's going to be C2, all this
No,
stuff.
that obviously would be.
This is why you have
Well,
minus
there's really only one mistake you can make.
yes, you do not have to worry about
For these next ones.
Well, actually, that wouldn't be so bad. It would just look like a right triangle.
What if it looks like one? How do you know that?
How would you know? Because the angle isn't 90 degrees. Well, I'm actually, if you only get one angle, that's true. You only get one angle, maybe it's a right triangle. So you don't know. But the only mistake you can really make is if you draw an acute angle triangle and two
Yeah.
sides of acute.
That was my point, except you
Yes.
had the words to that. It's like that.
Are these small bees or big bees?
So they're supposed to be, these are big, these are supposed to be small.
The
Size are small,
yeah. I mean,
these are supposed to be, I don't know, they're not within the sign.
okay, so these are all capital.
No, they're supposed to be small. If that helps you out, go small, except for whatever's.
Is this okay?
So be small a squared, right?
Oh, you're too far ahead. We'll get to that today. Okay, so
Everything outside the cosine thing is supposed to be four. Not supposed to be.
problem number 1. I haven't figured these out. Somebody tell me what the angles are.
67 degrees, 23 degrees.
67, 23, and what?
90.
90, and what are the other sides? Let me write these down. I just want to make sure. 67, 90? Oh, yeah, of course. 90 degree angle. Okay, and what are the other sides? It was 27.
10.55, 24.85.
Okay, so
Which one?
And those
When
are
you're done with
if someone didn't get that and is confused, please let me know. We can go over it.
square root it.
Okay, that's fine.
Oh, square root, sorry.
We'll see how I do it.
When you're
Maybe
done, you square root it.
maybe I'll do it different from, maybe I'll do it the same. Okay, so C, remember it says C is the hypotenuse. These are right triangles. So C is 27. And I'm just going to call this angle A, and it's 23 degrees. So the first thing I'm going to note is little a over 27 is what? What trig function is that?
You're gonna see this.
Sine, right? Opposite over the hypotenuse, 23 degrees. So on your calculator, you could just say A equals 27 times the sine of 23 degrees. And what do I get? I get 10.55, approximately. Okay, so that gives me this side 10.55. The next thing I can do is I can say, this has got to be little c. Little c over 27 is equal to the, what trig function of 23 degrees? Adjacent over the hypotenuse? Cosine of 23 degrees. So again, c equals 27 cosine 23 degrees. All right, let's see what that is. 27 cosine 23 degrees. I get 24.85. Is that right?
This is number one?
Oh, yeah, that's number one.
Yeah, that's what I got.
Okay, so now I've got, I want to slow down because you see how we did those? Sure. And then the last thing we don't know is this angle. That's actually pretty easy. It's the complement, right? So this plus this has to be 90, so 67 degrees. Okay. All right, let's try this again for number 2. Someone wanna tell me what the what they got for number 2? Notice this very exact. I don't do this usually. Exact. Does anyone know what the difference between M angle B and angle B is? Measure of, yeah. I mean, an angle is an angle. It's like 2 rays. But measure of the angle is, you know, degrees or radians. Okay, so B is 67. Wait a minute. Is that the same? Is this the same triangle?
Basically, yeah.
Oh.
But
How annoying.
obvious is different.
Well, then that means the measure of angle A has to be, what, 23 degrees. And the measure, we know, of C is always equal to 90 degrees. Right? So, what do we say here? C, that's a hypotenuse, is 72.
Square root.
So, oh, this is the same problem. Oh, wow. So, the only difference is here I'm multiplying 27 by the sine and the cosine, and here I'm multiplying 72. And no one pointed it out to me. Okay. How about number 3? What are we getting for the, you've got sides 428, 797. What was the hypotenuse?
904.
I'm sorry, 904. Okay, does everyone know how we got the third side, right? The right triangle? Pythagorean theorem. Okay, but now how are we going to get these angles? Okay, how are we going to use the law of sines to get? So we would say like the sine of A over 428 equals the sine of B over 797 equals the sine of C over 904. What's this? What did we decide the sine of C was? It's a 90-degree angle, so what's the sine? 19? That's what the angle is. What's the sine of the angle? 1. Okay, so I know that the sine of B over 797 is 1 over 904. This is the question he asked earlier. Can you use the law of sines? Yeah, but. Right? So I could say sine of B equals 797 over 904. I get that from here and here. And sine of A is 428 over 904. And then I can use my handy inverse sine button. Right? Okay, I see some questioning looks. Does that mean you're not sure? Or does that mean I should go on? Question? Yeah, you look like you're. Is that just a look, or you're confused? Are you trying to communicate confusion here?
No,
okay. Did you got the problem? Okay.
Yes.
Okay. All right. Finally, I have problem 4, which just looks a little simpler than 3. So the sides are 11, 21, and hypotenuse. Hypotenuse is the square root of 11 squared plus 21 squared.
Yeah.
Okay. Square root of 121 plus 441. We got a point plus.
But that's not
3,
that's
5,
how do you make it
562. What's the square root of 562? I can't do it in my head. It's about 23.7. Okay, so now I have 3 sides. I can use the same strategy. Okay. Has anyone not tried 5 yet? Everyone tried 5? How was 5? Yes. It was pretty good.
I'm pretty sure you had to apply this law. No, you just do it inverse.
You should say that with confidence. Because it sounds like you know. Sounds like you know. So we've got some kind of triangle here. 37, 28, and then the side opposite D is 14. Is that right?
Yes.
So what's the third angle?
Yeah, he does it.
Yeah.
I mean,
Shall I do that in my head? Or should you do it in your head? What?
Really weird way.
Okay, so you were saying you're going to use the law of cosines here, right?
There's something missing.
Tell me what do I write?
Pieces I thought missing.
What do I write here?
How do you so missing?
You just did this at
It should be by this one. Oh, yes.
I need a lot of time for this. I know we're talking about cycles.
That's something you shouldn't have. This
You guys doing 5 now?
28.
Okay, why don't you listen up for a second? Hold off. Hold off on 8. What do I write down for 5? Okay.
14 over sine 28.
Well, let's write it out like in one of those forms, so that people know where it comes from.
So
Sine of, just say sine. Are you going to do the law of sines or the law of cosines?
I've decided to do law of sine.
Okay, all right. So sine of
37.
57.
37.
37.
Over.
We'll call that. I'll just call that x. Okay.
Sine 28 over 14. Isn't that lowercase?
It's the sine of the angle over the opposite side. Okay? So sine of 37 over x, sine of 28 over 14. And again, if I do a real quick, real quick algebra here.
17.9.
17.9, okay. Now, I have to tell a little anecdote here. Somebody in this class was smarter than the teacher, and I don't mean that in a good way. Somebody on, I think it was on the quiz, yeah, it was the quiz. So, instead of like, I was hoping they'd give me a number or something. It said something like, what's the sine of like 27 degrees? And they said, it's the sine of 27 degrees. Isn't that smart, wasn't it? Because I said, if I don't say whether I want an exact or not, you could do it either way. And the only way to write this exactly is just this, right? I don't know who you were. I don't remember. Keep it, you know. Next time I'll have to say.
You get credit for that, right?
Yeah, I have to. Yes.
Is there a way to essentially reverse engineer a sine or something like that into a fraction of values or something?
Sine is also.
Okay, I want to know what you mean.
I don't know, a way to
So I mean, like if I gave you some number like 2, 3, 7, 1, 2, 9, 6, 4, 3, 2, 7, 5, and can you turn that back into a sine?
Well, I mean, instead of, to essentially get an exact answer from that sine thing, instead of just having sine, actually have a fraction answer.
So we say if you were to actually compute that, and it would give you some decimal, and then change that decimal to a fraction. Make it
Oh, good mathematical question. Right. So the real question here is whatever we're looking for, sine of 27, is it a rational number or an irrational number? That's the question. If it's a rational number, you can write it as a fraction, some fraction. If it's irrational, you can't. Now, how would you know? right? Well, it's easy, well, how do you answer this question? I mean, you know, we get these strange numbers out of the calculator and then it's done, right? Because we've reached its limit of accuracy. But we don't really know what happens beyond here. It is conceivable that for some sine or some cosine, one of two things will happen. Either at some point you'll just get a bunch of zeros going on forever, or it could repeat. It starts repeating, you know, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now, how would you know that it's going to keep repeating forever? If I told you it was, you know, if I made that, you know, 0.739, 1, 2, 3 repeating forever, then you would know it is. But okay, that's me trying to give you the honest answer. Let me give you the practical answer. Anything that comes out of the calculator that doesn't stop very quickly is going to be irrational. It's not 100%, but it's, you know, extremely unlikely. So you're not going to find an exact, you're not going to get something like this that's going to end for some, except for some specific cases, which, yeah. I mean, even, you know, what are the sines and cosines that we know that are nice? I mean, there's 0, there's 1, there's -1, there's 1/2, -1/2. You know, these just come out of, you know, some angles we know. Those are the only real nice ones we've run into. Now you could say, well, what's the angle, what's the inverse sine of, say, 1/3? Well, now you're going to have a crappy looking angle that's irrational. So, this is actually, you know, if we start talking about this, you know, you'll have to stay till midnight. There's a really interesting branch of mathematics that ends up, it's not what it's all about, but it ends up dealing with this stuff a lot, called analysis.
Oh.
And it's fun. And you learn all sorts of interesting things about the number line that you just can't believe.
Do they have that class here?
I mean, I'm trying to think of a good example. Well, here's kind of a abstract problem that sounds like a real problem, but it's not. So if you take, we're going to have a square dartboard, and goes from 0 to 1 and 0 to 1. And then there, if you can imagine, there are lines here. There are lines here for every fraction. Right? So every, I'm not really drawing it very well, but just imagine every possible fraction has a line. So you have a dart, and it's got a point, just a single point. You throw the dart, and you close your eyes and throw your dart, and you can't miss the target, right? And it bounces off the walls and hits the target. So what is the probability that you're going to hit the intersection of two lines? In other words, you're going to hit a rational number horizontally and a rational number vertically.
How do you even calculate that?
Anyone. Any fraction.
You take it to the extreme, sorry.
Well, no, the probability wouldn't be greater than 1, right? So like if you're guaranteed to hit one of those lines, then the probability is 1. But there are other numbers there, right? There's things like pi, like, well, say pi over 4. Yeah, pi over 4, that's some point here. You could hit that one, right? So what's the probability you're going to hit one of those lines?
How do you even figure that out?
Analysis. So it turns out that the answer is 0. It's not like really, really, really small. It's 0, which doesn't seem to make any sense, right? You have to have at least some chance of hitting one of those, right? But there are a lot more points that aren't rational. And by a lot, I mean
Infinite?
infinitely more. Okay, I'll tell you one other good one I like. Professor told us this once, and it was just beautiful.
I should run mine 2 years.
So, how do you know there's an infinite number of integers, right? But there's also an infinite number of numbers on the number line, right? So, how do you, apparently there are more numbers on, you can just listen for a second. I'm just, you'll either be entertained or you'll write me up a terrible teacher. I don't know how that works. So how do you know that, if there's an infinite number here, an infinite number there, how do you say there's more of these? Well, this is what he said. He said, if you had an infinite number of time, you could count all the integers. But an infinite amount of time wouldn't be enough to count all the real numbers. I just thought that was great.
So,
If you have an infinite amount of time, you can count up all the integers, but you can't count the number of real numbers, even though.
You get stuck at the very first decimal place, basically. You get stuck at the very beginning trying to get all that real numbers.
Well, that's another way to look at it. Yeah.
so it's like
All right.
a little bit
All right,
more.
Chris, you've totally thrown me off today. So now you get to finish. No. All right. We did we do number 5? Yeah, we did number 5. How about number 6? 6, you have to use the law of cosines. Anyone here not get to 6 yet? Okay. So, it'd be nice to have that in front of you. How do I do this? Get rid of this one. So I've got sides 8, 14, and 15. Does it matter which? No, it doesn't. Okay, what should I make A? 15 squared equals 14 squared plus 8 squared plus 2, minus 2 times 8 times 14 cosine of the angle opposite A, right? So with your calculator, you can just write 15 squared minus 14 squared minus 8 squared over negative 2 times 8 times 14 is the cosine of A, or just find the inverse cosine of this. That was good, wasn't it? And if we want to find the cosine of B and C, we just have to rearrange these. Anyone want to tell me what they got, just so everybody can compare their answers? For number 6, yeah.
I got angle A was 81.0. Angle B was 67.20. And C was 31.78.
Okay, anybody, anything terribly different? Want me to stick with my calculator to figure it out? Right, yes.
I don't say earlier. It was when you were saying measure of angle, and then when you say measure of angle, is that saying between degrees and radians, or?
No. This is kind of a geometry distinction.
Yeah, I'm just looking at number 7. It says
If-
equals 10.
If I draw a picture and I say, this is angle A, and this is angle B, this is angle C. So I could write that angle A, angle B, and angle C. These are objects.
Oh.
They're angles.
Yeah.
But the measure of the angle is a number. So measure of angle A is just some number, which could be in radians or degrees.
So it doesn't really affect our purposes here.
Right.
Thank you.
It's a nitty distinction that I sometimes will make and sometimes I won't. Okay. Has anyone done number 7? Anyone got the solution to 7? I see 2 hands. Has anyone tried 7 and is confused? You should be confused.
Say again?
I think, unless
Isn't number 7 the same as number
They
8?
put one in front of triangle then. He says they should be confused.
I don't think the same problem, but it's the same kind of thing.
they're supposed to be different. Maybe they're the same and I made a mistake. Let's take a look at this. It says, got angle B, except I'm using small letters here, and B is 5. A is 10. That's angle A and C. Okay, so B is 23 degrees. So what am I going to use here? Law of sines, right? So sine of 23 over 5 should equal sine of A over 10, right? So sine of A should equal 10 times sine over 5 should be 2 sine of 23. So what's this? What's 2 times the sine of 23? Sine of 23. That's that's point 0.78. Right. So yeah, it's supposed to be different, but that's okay. You didn't know that. So the inverse sine of 0.78 is 51. Right, 74, so it's 100.
105?
Hmm?
Or 106?
106, yeah, about that. And now I just have one more side I want to find.
You just do all signs, right?
Yeah.
Yes.
I'm not doing the same thing on number 8 doesn't work. You get an error on the calculator.
Oh.
It's either that triangle or there's 2 solutions.
8 doesn't work.
There's no difference. So I think I have an answer for this one.
It's the same.
I think maybe my hint was on the wrong one. Take another look here.
Whatever he's got up there is no triangle. You get an error.
Shouldn't we be getting 2 answers for number 7?
Maybe.
Because it's an angle up and 2 sides.
I sure wish I had a protractor here. Well, running out of board space here. Now I could create a 23-degree angle. I could use trigonometry. So let's say I draw okay, so this is 20. And this is 20 inches, right? And I want this to be 23 degrees. Oh, good problem. So how high up here should I pick a point? Well, I want the tangent of 23 degrees, my x, should be equal to x over 20. So x is equal to tangent of 23 degrees. So what, somebody want to figure that out for me? Did I do that wrong?
Which is the multiplication to bring the 20 over to the left side?
Oh, I'm sorry. I meant that. Yeah. 20 times the tangent of 23 degrees. How much is that?
8.5.
8.5. Okay.
Close enough.
So now I know what a 23-degree angle is. Okay. Having done that, let's look at that problem again. So it says, this is B, this is 23 degrees. A is 10. All right, so I'm going to measure 10. Actually, I'm going to do it double. I'm going to measure 20. 2 inches equals 1. All right. And now, this can go on forever. You don't know how long this is yet. So now, what was the other side? 5. So I want 10. Where's 10 here? So that's 10. Who said there should be another answer? They were right.
For number 7?
Yeah. That's also possible. Why didn't we get that? Why didn't that just pop out? Let's take a look again. Let's go look at the law of sines again. So the law of sines says that sine of 23 over 10 equals the
Isn't it 5? Yeah, it's 5.
oh,
Sine 22 is 5.
all right.
That's
Equals, this is 10, so it's either this angle or this angle. Right?
How do you figure out each one?
I'm working on it. Really, I'm working hard here. How do you figure it out? So the sine of 23 equals the sine of x over 10, right? So let's put all this stuff over here. We have sine of x equals sine of 23 over 5 times 10. For x, I'm going to convert this to 2, right? Is the sine inverse of 2 times the sine of 23 degrees. Okay. And the sine of 23 degrees, we decided 2 times the sine of 23 was what?
51.49 degrees?
Equal to 0.78. No, wait. Yeah, 0.781.
Wait, what?
You sure? Is that inverse?
No, wait. You're right, I didn't do the inverse.
It's possible.
It could be less.
No. Okay, Okay. 2 sine of 23 equals about 0.781. The inverse of that is 0.781 is 51 degrees, right?
I'll do the whole thing.
51 degrees, right? Okay. This is where today's lesson meets Tuesday's lesson. So the principal value of inverse sine of this is 51 degrees.
Oh, so we'll find another one, we do 360 minus that, right?
This is a sine here.
And so the other side.
This is going to be 180 minus 51 degrees. Oh, math is tricky. So 51 degrees and what, 129.
How about the range of inverse sine from -5 to about?
I'm sorry?
The range of inverse sine.
I-
The range of inverse sine? Or
The range of inverse sine. Well, okay. I know this is complicated, and I know I haven't said it as clearly as possible. Right? You want inverse sine to be a function. You have to do something so that it only gives you one value. Right?
Oh.
Right? But you can pull, out of the relation, you can pull multiple values.
So the
Now,
range-
51 is one of the things you can pull out of this.
and then 180
51 plus 360 is another value. Okay, so that would be 411. But this is a problem with triangles. And triangles do not have angles of 411.
Which is why I understand now.
Right? Does everybody get that subtle distinction there? However, another number you can pull out of it is 129. And triangles can have angles of 129. Right? Now, lest this seem really, really scary and confusing, this only shows up when you're doing side-side angle. So when you're doing these problems and you want to stay out of trouble, the question you want to ask is this a side-side angle problem? If it's not, no worries. If it is a side-side angle, one possibility is there are two answers. Okay, now what happened with problem 8? Anybody? What happened? Did everybody get to problem 8? Oh, all right. Everybody take a minute or 2 or 3, look at problem 8, and then when I've heard sufficient number of groans, I'll say something else.
Remember, it's kind of similar to that.
Well, oh, it is?
Yeah.
Yeah.
Uh-oh. Are there 2 solutions?
Well,
Oh,
actually,
we
the problem,
can't even get a solution.
we get an error.
Yeah.
You're not supposed to say that out loud. You're supposed to just groan.
Well,
What's going on here?
that one's not actually a triangle. I'm just gonna-
You know, you're gonna have to, you keep that up, you're gonna make you run the class. Pay no attention to that man behind the curtain. I guess I'll start putting this up here in anticipation.
I'm a dedicated man.
takes a little longer to do on the side.
73 degrees.
It's old tracker. Like it's a display or something.
That's not a domain, right?
It's a good line by from the career keys.
Or anything else.
Or anything else. That's it should be just everything else.
Is anybody still on their way to Groningen yet? Or is everybody got there? What happened? What happened? So, sine of 73 degrees over 54 equals sine of x over 73. Okay, so sine of x equals 73 over 54 times sine of 70. Wait. Am I mixing up numbers? No. A is.
The 60 degrees.
I messed it all up. Wait, that's right. That's 63. Okay, 63. 66. Okay, so before we, and set sine of 70. So before we go on, let's figure out what 63 over 54 times sine of 73 is. 63 divided by 54 times sine 73. That's equal to 1.11.
She's also deaf in her left ear.
Okay.
Yeah.
What's wrong with this?
Sorry.
The sine of something is 1.11. That's impossible. Thank you. So why did this turn out that way? It turned out this way because if you draw this carefully, you'll see that even if this was like a right angle down here, 54 would not reach. So another hazard of SSA, the SSA we get, here we have two answers. Here we have no answers. There's one more possibility.
We can have one answer.
Okay, now, that was the easy question. The hard question is, when will we have one answer? Does my diagram give it away? You're only going to have one answer when this angle is 90 degrees. Okay, so, Wiz in a week from, Tuesday. Midterm, right, thank you. What will the hard problem on that quiz be? Yeah, probably be an SSA. That'll be the hard one. Why would I do that? What do you mean? Because I can. No, because
Make it worth triple points.
if I make it worth triple points and you get it wrong, then you fail.
Bonus points.
Bonus
points.
Okay. Where are we? Oh, we have a few more minutes. There's a big homework assignment. There's a big homework assignment. There are lots of problems solving triangles. I encourage you to do as much as you feel proficient at it because it's the major new component that will be on the midterm. The midterm will also, we're gonna have a review, but it'll also have everything we've done. But that's the major new component, solving triangles. And really, this is, to me, this is the heart. This is what we've been working for with trigonometry. We want to. It sounds kind of dumb. We want to figure out how to solve triangles. This is really practical. Who here has not heard of triangulation? Who has heard of triangulation? Everybody heard of triangulation? Who knows what triangulation is? Strangulation. Oh, you do? Okay. Triangulation is solving a triangle. Right? Okay, who here knows how GPS works? Yes, actually, it's mostly triangulated. It's more complicated than that. I mean, you've got the Earth, and you got these satellites out there. You're sitting there with you got your iPhone 6, right? Or whatever, your GPS. So, we're not quite done. Does anyone know how your iPhone figures out the distance to these guys?
They triangulate.
Distance. Distance. We'll get to the trigonometry. How does it figure out the distance?
They know the distance between each other. Each other one knows the distance between each other, right?
Yes, actually, the satellites do know how far they are from each other. That's right. They don't know where you are, but so how do they know? How do you know how far you are from the satellite? Difference. No, that's a different. So okay. So anybody here program iPhones?
Yes.
We're just giving you a hard time.
Yeah. So the iPhone, and I don't know how the Android works, but it gives you different levels of location. So the most stupid level of location is it just kind of finds out, like, it looks at your IP address and looks up at a table and finds out you're in Texas or something like that. But if you're willing to spend a little more power, it will try and triangulate cell phone towers, which is kind of what this diagram is about. Again, is this question, how do you know, you can find the angle, right? Maybe if you have more than two towers, you can get a little more information. Then you don't actually need to know how far you are. But that doesn't work. That doesn't work here. You actually have to know how far you are from the satellite. And the way they do that is you're listening for the satellite, and it has a signal, right? And embedded in the signal are timestamps, extremely accurate timestamps, like we're talking down to like a billionth of a second. And who knows how fast signals go through from the satellite to you?
I don't know, but the satellite knows for sure. I don't know, but I'm sure the satellite knows.
Everybody should know how fast do radio waves go. No physicists here?
AM or is that?
Doesn't matter. They all go like pretty much the speed of light, right? So actually, this is pretty complicated. I don't actually know it completely, so anything I say might be a little wrong. But they have time signals. They go at the speed of light, and I've heard that in order to get the last bit of accuracy out, they have to put in a correction. It's called a relativistic correction. That's what happens when you get close to the speed of light. Funny things happen, like time slows down and things compress. Physics, not physicists, you don't care. All right, but anyway, so there's a cell tower triangulation, and then if you really want to spend a lot of money, I mean money, but power. You know, these things take power. You do GPS, which is, you know, looking for these towers. I'm sorry, looking for these satellites. So, okay, so here's a question. This is not in the book. This is not on the exam. But let's say I have 3 towers. And let's just say these are like 10 miles apart, and these are 5 miles apart. And let's say they're in a line. We'll make it easy. And we know this angle, we can measure this angle, and we can measure this angle. So how would we figure out where we are? Does anybody have any ideas? I'm sorry, visit what?
Just as far from
Well, okay, the law of sines. See, the law of sines only works for one triangle at a time, right? Well, wait a minute, look at this. Let's call this x for a second, right? So, I'll call this y, this z. And let's call this a b. So what does the law of sines tell us here? It says sine of a over 5 equals, oh, we don't know. We don't really know anything yet. How about this angle here? Call that C, we'll call that D. So how about sine of C over X? Oh, this is an angle too, equals sine of E over X. Oh. What does that mean? I didn't do that right. Homework assignment. No. All right, is everybody worn out tonight? Okay. All right, I'll be around for questions for a while. That's all. We've done those problems in practice. We'll talk about them Tuesday.
Usually use AM and FM radio.